I'm Anil Kumar, and in this video we'll learn how to find solution of a linear trigonometric equation using special triangles. Okay, so we'll actually write down all our answers in exact value. So we'll use special triangles to solve the given equations. In the previous two videos we learned how to find solution using the graph of trigonometric functions and also the calculator. Now special triangles, what I mean to say is we have three special triangles. One is 45 degrees, 90 degrees, 45 degrees. The other one is 30, 60, 90, which okay, let me draw like this. It looks more like 30, 60, 90. Okay. So in these triangles, this is 45 or pi by 4. These two sides are equal, is right triangle. If I consider each side as 1 unit, then the hypotenuse is square root 2. In 30, 60, 90, pi by 6 is, let me write pi by 3 here. Pi by 3 is 60 degrees, and the sides are 1, 2, square root 3, that is 90, and this is pi by 6. So that is our 30, 60, 90 triangle. We'll use these triangles to solve some trigonometric equations. Another thing which we are going to use to solve trigonometric equations is the cast rule, right? So these are the basic tools which will help us provide answers for our equations which I am going to give you. Cast rule is that all are positive in quadrant 1, sine in quadrant 2, tan in 3, cosine in 4. All students take calculus is the other way to remember it. All silver teacup is the way I learned it, right? Okay. Now let me write down a few equations. So let's begin by sine theta equals to, let us say, 1 over square root 2. We'll try to find solutions using these triangles, and then we'll find solutions for cos theta equals to, let us say, square root 3 over 2, and tan theta equals to, let us say, 1. Let's take positive values first. Now the solution for sine theta equals to 1 over square root 2. Whenever you get things like square root 2, square root 3 involved, you have an idea that we can use special triangle. Positive for sine theta means that we are looking for two solutions. One of them will be in quadrant 1, the other one in quadrant 2, if we are considering all the solutions in this domain of 0 to 2 pi. Now when is sine 1 over square root 2? 1 over square root 2 is for pi by 4. So in quadrant 1, the angle is pi by 4. So first find the acute angle. So we say alpha, so basically we write this always as sine alpha of 1 over square root 2, okay. And then we say alpha is pi by 4. So alpha is the acute angle. So first find acute angle. Now we say, well, for this particular trigonometric equation, we are looking for two solutions where the acute angle is pi by 4, and since it is positive, so we have two solutions, pi by 4 and 3 pi by 4. Got the idea, right? So we said theta, the principal angle is pi by 4 and 3 pi by 4. So for both these, sine theta is 1 over square root 2. In this domain, therefore, we have two solutions. Correct? Now let's look into cosine of square root 3 over 2. Now in this particular case, we'll again consider cosine alpha positive value. I know positive is given to us, but still. So we are looking for now two solutions, and these solutions will be in which quadrants? Cos is positive here, so that means quadrant 2 and quadrant 1 and 4. Now alpha is square root 3 over 2, means adjacent side over hypotenuse, so the angle is pi by 6. So we get alpha as pi by 6. So that is the acute angle. Is it okay? So what we are looking for is pi by 6 is my acute angle, so these are the two positions. Here the acute angle is pi by 6. Therefore theta should be equals to, in quadrant 1 it is pi by 6, and in quadrant 4 it is 2 pi minus pi by 6. Do you get the idea? So we have our answer as theta equals to pi by 6, and 12 minus 1 is 11, so 11 pi by 6. So these are two solutions for the second equation. The third one is tan theta equals to 1. Now can you tell me when is tan theta 1? Well, tan theta is 1 for pi by 4, opposite over adjacent side. So we know we could write this first as alpha, right? I know it looks bigger, longer, waste of time at times. So tan inverse of 1, so basically it is pi by 4, correct? Now since tan is positive in two quadrants, that is, it is positive in quadrant 1 and in 3. So this answer is pi by 4. The other answer is pi plus pi by 4. So theta is equals to pi by 4 and pi plus pi by 4, correct? So pi plus pi by 4 is 5 pi by 4. So we have two answers. So theta 1 is pi by 4, and theta 2 is 5 pi by 4. You could write like this also. So that is the way you can use special triangles and write down your solutions. Now let me take few examples with negative values this time. So we will say sine theta equals to minus square root 3 over 2, cos theta equals to, let us say, minus 1 over square root 2, and tan theta equals to minus 1 over square root 3. Now in this case, how are you going to give solutions? So let me show you fast way of doing it for all three of them. Since you have understood the concept, sine is negative in two quadrants and these are the two quadrants, right? Cos is negative in these two quadrants, correct? Tan is negative in these quadrants. Is that okay? Perfect. First step is to find acute angle. So we will say alpha is equals to sine inverse of positive value always. Acute angle, all are positive in quadrant 1. That's the reason. Okay. Now sine inverse of square root 3 over 2. Well, 3 over 2, sine is opposite over hypotenuse, angle is pi by 3. So we get this acute angle as pi by 3. You get the idea. But the solution is, one angle is this, right? The other one is that much. So we have two solutions. So we say theta is equals to pi plus pi by 3. This is first answer. The other one is 2 pi minus pi by 3. Do you get the idea? So that is how you get two different solutions, right? So which is 3 plus 1, 4 pi by 3, right? So let me push this page a bit and then write down the solution. So one answer here is 4 pi by 3 and the other one is 6 minus 1, 5 pi by 3, correct? So these are the two solutions for the given equation. In case of cos theta equals to minus half, we know alpha, the acute angle, will be, when is it 1 over square root 2? I'm saying half, but it is 1 over square root 2. 1 over square root 2 is indeed pi by 4. So alpha is pi by 4. So two solutions here will be theta equals to, now this is pi by 4, that is pi by 4. So we have pi minus pi by 4 as one solution and pi plus pi by 4 as the other solution. So the solutions are 5 minus 1, so 4 minus 1, which is 3 pi by 4, and 4 plus 1, 5 pi by 4. So we have two solutions in this domain. For tan theta to be negative, we are looking for quadrant 2 and quadrant 4. 1 over square root 3. 1 over square root 3 means pi by 6. So alpha is equals to pi by 6. You get the idea, right? Now, here, this is pi by 6. That is pi by 6. So theta is pi minus pi by 6 or 2 pi minus pi by 6. You get the idea, right? So pi minus pi by 6 is 5 pi by 6. So we'll write here 5 pi by 6 and the other one is 12 minus 1 as 11 pi by 6. So that is how you get the answer for tan theta equals to minus 1 over square root 3. Correct? So these were very simple ratios, sort of equations, right? Basic equations which you should know how to solve. And now let's move on to the next set where we'll have a linear equation kind of, and we'll see how to find solution using special triangles and also calculator. Thank you.